Hi everyone, so this video is going to be about string split in Microsoft SQL Server. I've got 2019 Developer Edition up and running. The purpose of string split is to take a long list of tags, so comma separated values, and split it out into a table. But what we're going to do is try and move away from that model of keeping everything in one field, comma separated, and having to do some fairly nasty stuff in the application to get that split out and into a SQL Server table, and we're gonna do it in SQL, so we'll see what we can do. So I'm starting off. I'm going to use my 5MinuteSQL database just here, and all the code that I present today will be available in a link in the YouTube comments. First thing we'll do is just create our first table. So our first table is going to be called videos, and it's going to contain an ID. We're going to have the name of the video and all the tags in a comma separated form, primary key on the video ID, like this. Okay, so let's populate our table so we've got something to work with, and we'll have a look and see what's in it. So you can see down here we've got 5 videos, okay, in our enormous database, and our videos have tags associated with them. So we have a funny cat video, it's funny, or cute, cat, meow, so on. We've got repairing a patio door, it's practical, it's door, it's patio, it's DIY. So what we need to do is create some kind of normalized database to examine our entities and link them together. So we've got two key entities here. We've got a video and a tag. All right, and what we need to do is create a video table and a tag table and a link table to connect the dots between them, and we can transform what we have here into that normalized view. And we're going to do that with the aid of string split. So if you're not familiar with string split, let's see how it works. Okay, imagine we have a string here. The string is ABC. Okay, A comma B comma C. We need to get that into a table form. We need to pivot that into a table. Now, thanks to string split, which was SQL Server 2016 above, we no longer need to mess around with pivots or with inchworm type methodologies or anything like that. We can just go ahead and say, okay, here's a TBF. Let's feed in our string and away we go. So let's see how it works. We execute that, ABC. All right. Now, a really important thing to note here is that a TBF is not something you put in a select part of a SQL clause, you put it in a from. The reason is that you're selecting from something that's already been computed. The TBF is a function that outputs a table valued function, okay? And the table that you have, you need to select from, just like you select from any other table. So you can't do select string split, blah, 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 from X. It doesn't work like that. You need to do it from string split. And that means that if you're going to involve another table in the mix, you need a way of combining those two tables together. Now, we're going to use a cross apply. And the reason we use a cross apply is that the function we are cross applying, that's string split, is applied to every row in the source data set. And because the function takes a column, a string, if you want to split, we can apply that on one column. Very difficult to explain, but very easy to demonstrate. So we write it like this. We say, okay, I want to bring back the value. That's our default column here. I want to bring back the value from DBO videos, and I'm going to cross apply it on the video tags column and use the comma delimiter here. So two parameters, video tags and comma delimiter. And you'll see that what that gives us is a great big long list of individual tags. Okay, so there's a couple of problems with this list. First problem is that we don't know what videos are associated with them. The second is that the tags themselves have a little bit of white space in there that we need to deal with. So we can solve both of those problems quite straightforwardly. We add in the video name into the query just here. We don't need to worry about cross applying here because we're looking at the tags. And we can fix the white space in a second with a simple ltrim. So on the left here, you've got all the videos, and on the right, you've got all the tags. So we're getting a bit closer to what we want, but we're not there yet. What we have here is a big denormalized list of individual links from video to tag, but what we don't have is a table full of videos, a distinct list, a table full of tags, a distinct list, and a way of connecting the two up. If you consider that we have 1 million videos, and each video can have, let's say, a mean average of 8 tags on it, then doing it like this is particularly onerous. It doesn't scale up very well. You've got 8 million rows, you've got lots of repeated information in the video name, lots of repeated information in the tag name. What we really want is two tables, one with 1,000,000 rows on the left and one with 8 rows on the right. Okay, we can save ourselves best part of 7 million record entries that way. A lot of space, a lot of performance overhead, and so on. So let's fix the extra space issue. What we're going to do there is just put a left trim, so get rid of all space on the left hand side, and that gives us a list we can start to work with. Now let's first analyze our data. We don't know from the top of our head how many videos we have, how many individual tags we have, so it's worth looking at that before we do anything else so we can get an idea of whether the output that we're expecting is worthwhile. The way I'm going to do that is I'm going to take our query that we defined earlier, a video name and tag, and use it as a query in its own right, as a data source in its own right. So from there, I'm just going to do a simple count and group by. And the count and group by will give us how many tags there are per video. Okay, so we're getting that little bit closer to having the full normalized model here. We can reverse that as well. If you wanted to know how many videos per tag, we can just simply flip that around. So we have every individual tag there in alphabetical order and how many videos are associated with that. That can be quite useful as an analytical query in its own right. So one more thing I wanted to show you, there's a lot of fuss made about business intelligence, BI, MI. That's been going on a long time. I'm involved in it professionally. I do a lot of work with it. Not everything has to be a pie chart. Okay, I'm going to very quickly demonstrate something here, a little bit off topic, and that's group by. Roll up and group by cube. Group by roll up is a way of grouping by sets essentially, and through a hierarchy, and group by cube groups by every combination. The Cartesian product of all your different set types. That sounds hideous and confusing if you're about to browse away and go, well, just tell me about string split. Fast forward 30 seconds or bear with me. So what we're going to do here is we're going to take our core query, we're going to wrap it in our subquery here. Let's call it foo, that ubiquitous name. We're going to just do a couple of is null replaces because the cube will, when it summarizes everything for one level of your hierarchy, it doesn't know what to call it, so it calls it null, which looks a bit ugly. So we're just going to call it all videos and all tags. And then we're going to put order bys on there to make it a bit more sensible. When we run the whole thing, you'll see the kind of functionality it gives you. It will give you for all videos and all tags, how many do I have? Okay, we've got 23. Wonderful. Okay, 23 combinations. Well, what about how many videos do I have with a funny tag? I've got 3. How many videos do I have with the patio tag? I've got 1. And it does it for every combination. That's what's so great about this. And you can use this as a data source when you're doing analytical queries, creating pivot charts, pivot tables, that kind of thing. So over here we can go, per video, or funny cat video, show me all the tags associated with it, and so on. So no more of that. First of all, we are going to create the tables in the format that we want. Okay, and in the manner of Blue Peter, we're going to have a quick look at the ERD, the entity relationship diagram. Now, this is a tool called QSEE SuperLite, well worth looking at. From Leeds Beckett University, free of charge. Looks a little bit ugly, but the functionality is obscene. It's a Dr. Dixon that's been working on it for years. Very, very good. So what we're going to do is work from our source table here, a big lump of data with ID, video name, and tag, which is a big, long, comma-separated list of stuff. And we're going to turn it into a 3NF, third normal form, ERD model here. So we've got a video on the left, got a tag on the right, and got a link table in the middle. So hopefully that's very clear to everybody. We've got a primary key on the video tag link table, which is just really a surrogate. It's there to enumerate. We have a video ID with a foreign key relationship after video. We have a tag ID with a foreign key relationship after tag. We have a one-to-many one relationships, and we have a date added as well. That doesn't have any bearing here, but it shows how you can add metadata to the relationship itself using this kind of paradigm. All right, so let's head back to SQL Server. So let's go and create our tables first of all. Oh, we've got foreign key objects, my fault here. We can drop them in reverse order to get around that. Okay, now we can create our tables again. And wonderful, and then we can populate our tables with the information. Now, there's a few ways of doing this, okay? I went with the method of finding all our distinct video names, all our individual video names with no duplicates, finding all our distinct tags from our string split query, de-tagging them all and getting a distinct list, taking the commas away, getting a distinct list, then inserting them into our video table, into our tag table, and then generating the links. So we can do that piece by piece. Let's get all our video names, get all our tag names, and now here it's going to look at the videos, look at the tags, and we're going to inner join back to our string split query. We're going to go and get those IDs, and we're going to put them in the right table, like this, okay? And that really gives us this model here fully populated as we want down the bottom. Now, in order to prove this, what can we do? Well, let's say we want to know which videos correspond to a given tag, a really common query. Show me all the funny videos in my database. Okay, you can't do that under the original model. The original model had all these string separated tag values. We can do that under our model now. So we're going to say, give me the video name from video, inner join off to my link table, inner join off to my tag table, where the tag equals funny. Dead easy, we've got some video names. That is a really great call to have behind a web interface. What about the other way around? We've got a video, songs about my cats, with apologies to Venetian snares, and for that video we are going to have a number of tags. So which tags are associated with the video? We simply flip around the same query. We have the link table in the middle, we have the video on the left and the tag on the right. We flip it around and we run the query, and away we go. So that's the end of this video, maybe slightly over 5 minutes. Thank you for watching. Make sure that you check out my channel. If you'd like to support me on Patreon, there's a link on the bottom, and see you next time. Thank you. Goodbye.